Hi everybody. Today I'm going to present on the topic implementing MPLS VPNs and monitoring the same using BGP. My project partner is Kiran Karthik Ilangovan. He belongs to NSSA department and I belong to Telecommunication Engineering Technology. So today we're talking about MPLS networks. So today talking about MPLS networks, MPLS is a layer 2.5 networking protocol. That is, it is present between the layer 2 and layer 3, which are the data link and the network layers of the OSI model. The main advantage of MPLS network is that it is very flexible, scalable, and it uses packet tagging, low cost overhead, and integrated quality of service. So what MPLS actually does? MPLS packets are directed through the network based on assigned label. Label is associated with a predetermined path through the network. Priorities can be assigned to data flows as per the requirements, and within each router, the incoming label is examined and its next hop is matched with a new label. So here, the label determines which predetermined path the packet will follow. It improves the quality of service and it has the capability to deploy and administer scalable layer 3 VPN backbone services. So what is the main advantage of MPLS network? So label lookup and label switching are much faster than a routing table or RIB. That is, this is because the lookup directly takes place inside the switched fabric and not the CPU. So these are the main advantages of the MPLS network. And the MPLS VPNs using BGP. So BGP is a routing protocol. It is a path vector protocol that is used to route between different autonomous systems. So what is the role of the BGP in MPLS VPNs? So VPN routes are distributed over the MPLS network by using multiple protocol BGP. It distributes the label across the VPN routes, and the VRF, which is VPN routing and forwarding, is used to isolate routing domains from one another. So as we know, MPLS is a connectionless protocol. So it can be used in huge enterprises to route between the different branches and to connect the branches to the headquarters. And it builds a foundation to deliver value-added services. So there are two levels of labeling in MPLS. The first level is the top labels. It directs the packets to the correct provider edge router, and the second label is which that determines how provider edge router should forward the packet to the customer edge router. So we have already discussed a few advantages of MPLS VPNs, but here are a few more. The first advantage is that it is a connectionless service, and this connectionless service can be used to establish connections between areas that are far apart, and this reduces the cost of laying cables for connections. And the second thing is that it has a centralized service, that is, it is apt for using in headquarters for it to connect with the different branches associated with it, and it has a huge scalability, that is, it can be used for large enterprises. And the security, as we know, the virtual private networks have good security, and several security aspects are followed to ensure security in a network. So MPLS helps to provide security, and it is easy to create, and it has flexible addressing. So each packet is given a label when in MPLS technology. So there is something called as the label edge router. It works at the edge of MPLS network and acts as entry and exit point to the network. So the main job of this router is that it pushes label in incoming packets and pops it out of outgoing packets. So an other router that is very useful in MPLS technology is provider router. It is a specific suppose in a specific context of MPLS based virtual private network. The label edge router functions as both ingress and egress router to the VPN, often known as the provider edge router. So the main protocol used here is label distribution protocol, which is used in between the label edge routers and the label switch routers. So this is about the flexible addressing of the MPLS VPNs, and then it provides increased functionality for BGP. It uses BGP to the fullest of its potential, and it is used to route the labels between the different networks that are present in an enterprise network. So the purpose statement of the project. So the purpose of the project is to set up an enterprise with the help of multi-protocol label switching VPNs and set up BGP routing protocol for monitoring the labels in MPLS. So distribution of VPN routing information. So how does it actually route the VPN information in a network? So as we already discussed, this is controlled using BGP extended communities, and VPN routes can be learned from the customer edge devices, and it is added to the BGP process. So the attribute values obtained from the export list of route targets associated with VRF, that is the VPN routing and forwarding, is used. The information obtained from VPN routing and forwarding is used for the BGP process. So the provider edge router learns about the different clients and the different customers it has using with the help of the customer edge devices. And BGP communication in MPLS networks takes place at two levels. So the first level is the internal BGP, which takes place within an autonomous system, and the next one is the eBGP, that is, it takes place between the autonomous system. So the provider edge to provider edge connection actually works with the help of internal BGP, whereas the provider edge to customer edge sessions are established by the external BGP. So BGP here enables members of the VPN to communicate with one another. Next is the MPLS VPN configuration. So how is the configuration done? CEF, which is Cisco Express Forwarding, is generally enabled on a switch. So the switch must contain MPLS, must connect to the MPLS network through Ethernet switch port, and VLAN should not be present in a switch, as it interrupts the MPLS process. And policy-based routing. This policy-based routing can be done is usually done by organizations, and it provides them the freedom to implement packet forwarding and routing according to their own defined policies, and it helps to enable quality of service and helps in cost saving and load sharing. So the specific PBR command that we use in the routers that we have used for the project is SGM prefer routing PBR, and the virtual routing and forwarding are dynamically assigned to an MPLS label, and as we discussed, the service policy applied on egress and egress routers in an MPLS network. Next is the MPLS configuration. These are the commands that we use for actually configuring a router, that is the provider edge router, to be a part of the MPLS network. And this is how the VPN is defined within a provider edge router, and a specific VRF name is given for further reference, that is future reference in the project. And this is the continuation of the commands required to configure a VPN on a provider edge router. So this is here comes the BGP configuration, and this is done this is the configuration that is done between a provider edge to edge router, that is between two provider edge routers. And this is between a provider edge router to a customer edge router. As we know, it is IBGP configuration, internal BGP configuration, whereas this is an external BGP configuration. This is the design of our architecture. So the headquarters is present in Rochester, which and there are 4 other branches for the same enterprise, one at Boston, one at Dallas, and one at Washington DC, and one at Buffalo. And each of the branch has its own support, disaster recovery support, and a finance sector, and a management sector, and a warehouse, and we have web servers connected associated with each and every branch. And we have installed web servers in 2 branches, one in Washington DC and the other at Buffalo. And the client that is present in Rochester should be able to reach the web server here at Buffalo, and the other web servers available in each network that is seen here. And this is the main MPLS core router that we have used, which does the major label, which can also be called as the label edge router, which does the label forwarding in this network. So this is a general architecture of the enterprise. That is, it has MPLS label switches and provider edge routers, and these are the different branches that we spoke about. One in New York, the other one in Rochester, which has the headquarters. New York is the data center, and office at Dallas, one at Boston, and the NDR at San Jose office. And here are the devices that we have used. The first is the router, which routes the traffic between the LAN and WAN, and a switch which provides access layer connectivity, and MPLS switch which provides inter-office connectivity for all locations by MPLS switching, a web server, and in this web server Ubuntu is used to run the Apache web server that hosts the enterprise website, and a client, Ubuntu client, is used for testing performance and connectivity, and the cloud is used to provide internet to the users. So this is a capture of the GNS3 and how the configuration is done. Configuration is done in the network, and this is the actual network diagram, as you can see, and the configuration that is done on the router associated to the Rochester branch. And this is the ping that is tracing the route to, it is a trace route which traces the route to web server from the client that is present in Rochester. And the tools used for this project are GNS3, which integrates PuTTY and Wireshark, VMware and Windows 7 client machines, and setting up GNS3. So GNS3 is a great software, and it is in this project it is integrated with VMware Workstation to attach computers to the nodes in GNS3, and it provides an amazing feature of attaching a real client running in VMware workstations in the tool. So this is the integration of Wireshark with GNS3. Wireshark is generally used to capture the packets and study the packets, which is helpful for beginners and even for professionals to understand what data the packet actually carries. Next is the internet connection. So since we are using a Windows 7 client here, it is connected to the physical NIC to access internet, physical NIC of the laptop that we use to access the internet. And in a nutshell, the presentation has covered various technologies and the advantages of the technologies used in this project, such as MPLS VPNs, BGP configuration, and the project statement is stated. The network architecture is shown and explained, and how it was implemented, the commands used, and the architecture of the whole network in the GNS3 platform was also shown. The tools used were discussed, and the advantages associated with each tool was also discussed. The results were put up, and the project demo comes along with the results. So we come to the end of the presentation, and the references are here, and these were very useful during our project. Thank you, and myself and Kiran Karthikeyangovan take great pleasure in presenting this to the class and to the professor. Thank you, and have a nice day.